we are asked to find the area of the region enclosed by the curves as shown on the interval from 0 to pi. We begin with a sketch of these curves and notice that they are our familiar sinusoidal curves but are sitting below the x-axis. So we need a y-axis and an x-axis and an interval from 0 to pi. Now, our y equals negative sine x has an amplitude of 1, so it goes from negative 1 to 1, while y equals to negative 2 sine x has an amplitude of 2, so it goes from negative 2 until 2. And now I'm ready to graph the negative sine curve, and I label it on our graph. Similarly, y equals to negative 2 sine x looks like this. And again, we label it. Now that we have sketched both curves on this interval from 0 to pi, we shade the enclosed region and label it with A for area. Let's analyze this region to determine if we should integrate with respect to x or with respect to y. For this, it is helpful to grab a vertical and then a horizontal line that we move through the region. So let's begin with this vertical line. What we need to observe is that we always have the same curve on the top and the same curve on the bottom. So we should be integrating with respect to x. Out of curiosity, let us also check whether we can integrate with respect to y. And so let's run this horizontal line through our region. And already here we see we have a problem, because on the left and the right side we both have the blue curve. That means we kind of have to split it, which is a little bit hard. And then here, if we look at this section right here, we have blue on the left and green on the right, but then we have another little piece of the area where green is on the left and blue is on the right. Clearly, integrating with respect to y is too complicated. Let us indicate on the diagram that we have decided to integrate with respect to x by drawing a vertical bar on the region. In general, we have that the area between two curves f and g, say, is equal to the integral from a to b of the upper curve f of x minus the lower curve g of x, integrated with respect to x. In our case, the area is given by the upper curve f of x is negative sine x, and the lower curve is given by negative 2 sine x. We have decided to integrate with respect to x, and we see that our bar runs from 0 all the ways through to pi. Let us simplify the integrand, and so this is the integral from 0 to pi of negative sine x plus 2 sine x dx. We can readily find the antiderivative, which is cosine x for negative sine x, and negative 2 cosine x for positive 2 sine x. We still need to evaluate this on the interval from 0 to pi. Substituting the upper bound, we get cosine pi minus 2 cosine pi minus, substituting the lower bound, cosine 0 minus 2 cosine 0. The values here are -1 for cosine pi, and 1 for cosine 0. That is a lot of brackets, so be careful when you write something like this up. The very first bracket evaluates to +1, and the second bracket evaluates to -1, which yields 2 square units for the area of the enclosed region.